Hi, welcome to my YouTube channel. Today I am going to tell you about how to define region in Silvaco TCAD. So please subscribe my YouTube channel for more such video. So let's start with the slide. And one more thing, please subscribe my YouTube channel and like I will make more video on such topics for like in future. Okay. So like you know that in the Silvaco there is like after defining meshing you have to define the region. So region is one of the essential thing for simulation. It may be in a cylindrical form, it may be in circular form, it may be in the form of rectangular, or maybe it in the form of cuboidal. So there is a many possibility in 2D or 3D way. So there is a reason is the important to define either in 3D or in 2D to run the simulation. That is the case, and so I will give you the way how to define. So I will give you the way how to define region with the help of syntax and simulations. Okay, so I will show you the syntax also in the below slides, and also show you the simulation at the end of the video. So please watch the video continuously. So the first syntax, like this is a one syntax, first syntax. I will explain you what it syntax means for a beginner. Like syntax one. So first way is region number one equal to x dot mean equal to 0 x dot max and y dot mean and y dot max. You have to define like this way. So you can define the region as a shortcut also, like reg is also okay to define the region here, and number you can define as a num also. So this is some you can say short syntax, so it will help you to write the code faster here in 2D mesh or 2D region. Here I am doing the 2D simulation, so I have defined only the rectangular mass. You can see that there is only x min, x max, y dot mean, and y dot max, not any z coordinate. So that means it is a 2D simulation. And so like you have to find the point where is your is x dot mean, where is your x dot max, where is your y dot mean and y dot max. And the first reason it is, so that is called reason number one. So how to do the coordinate thing, I will tell you with the help of paint. Let's say this is the region, like you have defined the this is first mass, like you have to define like these regions. Okay, in the mass you have to define these two regions, like assume it to be some region red and some region green. Okay, and let's say there is some in the your research paper or reference paper that there is a given coordinate that like you have to make it this much thickness. So you can understand like this, if it is given that you have to make a 1 micrometer thickness. So as I told you that in Silvaco all our coordinates are in micrometers. So it like if you write 1, it means that region like region x dot mean is equal to 0 and x dot max equal to 1. That means 0 is a micrometer and 1 is in a micrometer. So like this is in your research paper, some reference paper, it is given like that, like 1 micrometer and 1 micrometer. So and like sometimes in the research paper it is not given that x1, because that is maybe not matter there. So because for this calculation part, so sometimes it is not defined, sometimes it defined like you have to take some specified value like 1 micrometer. So you can take like assume to be 1 micrometer, I am assuming. So like you can define it as like you know that as you understand this is region number one. So I if I am assuming Oregon here, like here also you can, but that may lead to in negative one, and you know that we can easily deal in the positive side. Little bit harder to deal in negative sides to like coordinate system in the coordinate system. So to use in a positive system, so I am defining this as a Oregon for our for our way to write the code. So this if it is a 0 comma 0, assume it to be, it's not in the syntax, like this is a way you can define region in very efficient way. So I will tell you, like then this coordinate may be as per that 1 comma 0, and this coordinate will be you can say 1, you can say 0 comma 1, because x is 0 and 0 comma 1. Similarly this is 1 comma 1, and you can say this is 1 comma 2, yes, and this is like 1 comma 0 comma 2. Okay, So you can easily write like this. So for this coordinate you have to define like, so you can define x dot mean as 0 and x dot max, you know that it's 1. Here x dot max is 1. Okay, and y dot mean is 0 and y dot max is 1 for the red one. So for this material you have to write like this. Similar for below one, you know that x dot mean and x dot max is same. So like you can define like x dot mean similarly like 0 and x dot max as a 1 and y dot mean as a like 1 and y dot max as a 2. So this is defined like a reason in here. But the next like this is the some way you can define the reason here, and for that you can define the material also like for below one and above one. So this is some way. Now I will show you in the slide. Actually this is will be 3. uh, so now you understand the way like what it means, so you can easily draw that what it the reason how I define in the form of coordinates. And like this is some way, first way you can say for me, like I have defined in the some syntax order like syntax 1, syntax 2, how can you define here. One more thing, you can see that here I have not defined the x dot mean and x dot max. You can do that also for y dot mean and y dot max. You can ignore that and just define the x dot mean and x dot max. So why it is so, why I am not define the x dot mean and x dot max? Sometimes in meshing what happens is we define is location as 0 and location as a 1 for x dot m. Like for x meshing we define like this. Some spacing you can assume it, for now I am not giving here, but like this. So what happens is if you are not defining that here, as you see that there is no like x dot mean and x dot max here, so that means that it is assuming from the meshing only. So it you don't need to define there x dot mean and x dot max here if you define this way. So if like you assume you are using like full meshing location, full meshing location, so then you don't need to define the x dot mean and x dot max. But conventionally I will prefer you to do like this way because it is little bit not confusing that much. And also for a beginner and for a like if you have a experience in coding, you can use that method very easily. You don't need any extra effort or extra effort to do that. But for now, like as a beginner, you try with this reason statement. Now we go to like syntax 2. There is a second syntax way, like you can define as a like if texture layer type. Like if texture layer means you define the first layer above the second layer. Like you define like this, you can see that there is a thickness. So what happens is you are assuming some thickness of 0.02 over which you define the other thickness with 0.01 like this. So this is also a way you can see that region top thickness 0.02 and region bottom thickness 0. Material lgam and ny is equal to 5. So what happens with this, like when you don't need to define the y meshing here. If you define only the x meshing, if you want to not define the y meshing, so you can do like it is a some method by which you can avoid to write the y meshing. So what you can do is just define the auto mesh, and then you define the x meshing, and then you go down and define the thickness there. Like at the top, from the top, if you want to from top there is a thickness of 0.02, so from the top it takes 20 nanometer here, and the below one it takes 100 nanometer for bottom, and as a material as a gallium nitride, and below one as a aluminum gallium nitride. So like one more question you arise, that what is ny and ny2 and ny5? Like you know that for y what we have to define is meshing, a location and a spacing. But if we are not defining that, so that way we have to give that how much like in a particular location, like if my location 0 to 1, how much meshing line is there. So we have to define that as a ny equal to 2 and ny equal to 5. I will explain you more better. If you find any confusion, you can write me in comment. I will explain you there also and make a more video about that, because it is become longer video if I explain you all the things here. There's also one more thing is the sx and sy is there. So for spacing in x like between the two mesh node, and the spacing y between two y node, you can use these things. Now in the 3D, like you assume you know that already, like what happens in 3D. Z min and Z max is extra term which is coming here. And like one more thing I have done is up the top you can see that this is for the cylindrical. Like if you are doing some cylindrical nanowire, I will try to make a video on that also. Like I have made a nanowire, 3D nanowire, so I will make a video on that. I will show you the syntax also. But for that, for now, I will tell you that you have to define the r at minimum, like radius minimum, radius maximum. Z dot minimum means Z minimum, and Z maximum. You have to define the angular angle, a dot mean and a dot max. So it you can assume, like you if you visualize very carefully, then you can some cylinder with you can say there is a one like in the mid, it's something like this. You can assume it like you can understand like this. This is some cylinder. It is look like this, and this is the area where it is filled. So that is from that. And now comes down to like this is 3D and this is 2D. This is 3D syntax for rectangular or cylindrical one. And I will also tell you that you use mesh cylindrical for this one. If it you don't use mesh cylindrical, it will not be there and it will show error. Okay, so for this mesh cylindrical you have to use. For this one you don't need anything, just you have to do write mesh 3.d and it will run. Okay, and now comes to syntax, more syntax parts. Okay, this is something like I will tell you extra things here. Like reason number two, x dot min, x dot max, and y dot min, y dot max. You understand probably, right? In the Silvaco manual, there is some more thing. It's specified there. There is a conductor. Like sometimes what happens, as in the last video I have explained you that sometimes we have to take the topmost metal as a conductor because to specify it as electrode. So we that like electrode is a in Silvaco it is a metal only. So if you define as a conductor here, so it will automatically specify as a electrode in electrode statement. Okay, so you can define like at the top sometimes Jadon has taken as a conductor in the solar cell simulations. So you can define just conductor in the side of this like conductor, and you can define material equal to Jadano and conductor here, and it will like becomes like boolean expression integers. So if you write the conductor, it will turn on or true. If you don't write, it will remain false. Okay, one more thing, like sometimes you have to write a bigger the doping. So to avoid that, like if you are doing for uniform, you can just write acceptors, and it will acceptors and its concentration like acceptors 1e19 1e20. So it will take doping of p tab as a uniform as a 1e19. For similarly for donors, you can define like donors 1e20 something, it is like assuming some value. So it is assuming that uniform doping with n tab and 1e20 is the concentration. Like materials, as I explained you, you can define materials. And one more thing, like sometimes you don't need to define using materials, like some materials already present here. So you can like sometimes write, if you ignore the materials, you just write oxide there also, it will take that. Oxynitride also, it will take that. You don't need to write materials separately. You just write gallium nitride, it is also present. Sapphire, it is also present. Amorphous silicon is also present here. So you can define here all these things. Now comes to more about these things, like I have like added here also, like sometimes more like more person coming from for me, like how to define the like X composition. So you can just easily define X dot com for interstitial compound, y dot com for interstitial compound for Y composition, or for X composition. You know that interstitial compound one like something defect compounds, and that is something you can define like this. For strain thing, you can define cas dot strain, and you can like understand from what I have written in syntax specifies that the strain in the region is calculated from the lattice mismatch with the adjacent region. So there is a lattice mismatch. If you want to encounter in your simulation that thing, you can use with the cals dot strain. And if you are doing some LED simulation, you can use LED directly there in the like others point where I am writing others. You can LED and it will pre-processing as a LED. Strain, you can define the strain here also. Like there is some separate thing for strain. You can read that more better. Like if you go through that. And QVal, like quantum value, if you have to define, you can define like here also in this region. It will assume like that this region is act as a quantum well. This similarly, it will assume that this region is act as a strain. So this is some benefits. This is for substrate. Like sometimes what happens is we have to specify that this region is act as a substrate. For substrate, there is a some separate calculations going on. So for substrate, you can define like substrate in the region, like this region is a substrate. So that you region number one equal to x dot min, x dot max, and like substrate, you can add that will act as a substrate. So this is from my video sites, and like I will show you the now the little bit about the like syntax in Silvaco Atlas. Okay, so you are all familiar with this syntax. Actually, I have shown you on the previous video also, but here is the point is to explain you what is region number one equal to x dot mean and region x dot max and x y dot mean and y dot max. Like as I already explained you in the part of the video that part is how to define the syntax. So you can see that there's a region number one x dot min x dot max as a the material z and t. That means that it will allocate first allocate that location and then second allocate that location. So this is like you can see that. But one more thing, like as I told you that you have to assume it to be organ at the top, but for that you have to define the massing according to that. So like as I explain or as I do here that x dot m location equal to 0. So that means I am taking as a that point as a 0 comma 0. If you take negative some negative value like minus 1 or minus 1 comma 1, you can define as starting from minus 1 comma 1 minus 1 and this as a minus 1. So it will define that portion as a minus 1 1. So like whatever the way you define the meshing, you have to define the reason because so at the end, you know that the like the points where the meshing points lying, only the calculation is done on that points only. So if you define anything like any material here, but if the meshing point is not like better, so it is nothing. It will show you nothing. Okay, it will show you error also. So meshing is one of the essential parts. So you have to define the region and meshing in the synchronized manner. Okay, so that will be helpful to you. And second thing, like the second thickness, I have so told you that region top thickness 0.025 ny is equal to 20 and material silver, and similarly bottom one you can define like this, and you can define in the mid one also, or you can do like this also at the top. That means from the top the first layer is silver and the second layer is like assume it to be Z and T, second layer is Z and T, and you can define it also like this also, bottom so now like both have different meaning like so the bottommost layer like is the silver and the top the other bottommost layer is guarantee. That means the first is silver and then is guarantee is there. And similarly top, so it will first top is silver and then second top means it will override that top and it will becomes a topmost layer and that is now guarantee. So this is some syntax you can like understand this way, like also you can define as a top bottom also in separate way also. So this is way. And as I some given you method like conductor, you can define as a conductor, so you can define as a conductor also. You can define here acceptors also like this 1E20, so you don't have to define the full doping statement. I will make a video on doping one also in 2 3 days. In the 2 3 days, 1E like for donor you can define 1E20 something. You have don't have to do that much hard work to write the full doping statement if it is a uniform one. Okay, and that is the case. And also one more thing, like as I explained in the video, that if you define it as a conductor, that means that you have to define in electrode also. But as I explained you in the material section in the material videos, that if you define anything as a conductor, that means that that will act as a that material act as a metal. And if that material as a act as a metal, that means it is some electrodes. So it will if you not define that electrode, it will take some random electrode like region number X and region number like region number no sorry electrode number one and electrode number two something like this. It assume like that, but if you define that, then it have a name like train source, then it is easy to use that in our simulations. And one more method as on that video, it is that like if you can define it as like this. So if you are not defining x dot min, like why I'm not defining, like you can see that the x dot m and x dot m is almost same here, similar here. So you can just define these portions only and similarly define this portion only. It is also okay. But this code will not run because there is a two three syntaxes on on the one like. But I will not run this code. You can run this code in separate way. Like first you do for this one, then you try with this one, then you try with this one, and see the result what it is. Okay. Okay, and in the next video I will try to show you about the doping and electrode, and similarly at the like afterwards I will explain you meshing, and at the same time I will also show you about the different uh, codes given you, like in the vertical T-FAT codes also I will show you on how to run that code. And also one more code is on the nanowire. I will show you that many TFAT code is also available for like I have in the my blogs also, and I have the full codes available with me. I will share you that code also. So like please subscribe my channel, and if you feel any difficulty in my explanation, or if you find some error in my explanation, you can write me in comment. It will help me to improve. Thank you.